Hi, welcome to another tutorial for Quail, the discontinuous Galerkin Python code for teaching and prototyping. In this tutorial, I'll be providing an overview of the boundary conditions, or BCs, in Quail and how to implement a new boundary condition. First, let's start with the overview. The full mathematical details can be found in Chapter 2.6 of the documentation, which is in the GitHub repository. Here, I'll just be going over the basics and how BCs are handled in Quail. BCs are treated with either a weak prescribed or a weak Riemann approach. The classes associated with these approaches are in source, /physics, /base, /data.py. In the weak Riemann approach, the boundary flex is computed using the numerical flex, while in the weak prescribed approach, the boundary flex is computed using the analytic flex. Every boundary condition in Quail is defined as a class that inherits from one of these two classes. The BCs universal to all equation sets are defined in functions.py in the base module. The BC type enum class lists two BCs, state all and extrapolate. Now let me scroll down to the class definitions. First, let's start with the extrapolate BC, which follows the weak prescribed approach. The exterior boundary state is simply extrapolated from the interior. The state all BC follows the weak Riemann approach, where the exterior state is fully prescribed using a state function, such as uniform, which simply sets a uniform, non-spatially varying state. These state functions are also used for initial conditions and exact solutions. For more information, please refer to the tutorial on adding initial conditions and exact solutions. The test cases in examples /Euler /1D /smooth isentropic flow and scalar /1D Invissid-Burgers show how to specify these inputs in the input deck. Now let's go through how to add a new weak Riemann BC to the 1D Euler equations, which I will call mass flux. This shows how the exterior boundary state, denoted with the B superscript, is set, where the momentum is prescribed by the user, and the other state variables are extrapolated from the interior, denoted with the plus superscript. Please refer to the documentation for details on the nomenclature and notation. The new BC class will be defined in the Euler module in functions.py. Before implementing this class, we first need to add another member to the BC type enum class. So let's go ahead and do that. Now let's scroll down and implement the class right under the pressure out class. In the init method is where we can define any parameters associated with the boundary condition. Here I'm going to create a parameter for the user prescribed momentum with a default value of 1. Then we implement the getBoundaryState method. First, I'll copy the interior state. Next, I'll set smom to the slice corresponding to the method variable. Then I'll replace the momentum with the user-prescribed momentum. The final step is to map this BC to the 1D Euler class. So let's go to the definition of that class in Euler.py. And in the setMaps method, we update the BC map with the MassFlux class. These maps tell the solver which BC classes can be used by a given physics class.